We'll start with lesson 2. It's about database development. And we're going to talk about data modeling concepts and normalization. So first things first, what do you guys see? It's an Excel file. What? It's a
table.
Correct. Spreadsheet table. That's the keyword that I'm looking at. This is a table. What do you call this? That's rows. And this is called columns, right? So in Excel, you store data in a cell, right? Or you can say in a row. And you can also put respective names on these columns, which we can call fields as well. So let's say last name, first name, age, date, time. And now with that type of data, we can either put an integer without any decimal places, a decimal with decimal places, date and time, string. So we can do that in Excel. Also, we can do that in the database. Okay? So just so you know, spreadsheet kind of is like a database, but there's a lot of risk in using it as well. So now we talk about schema. So what is schema? Schema, think of it like your blueprint or plan something that you look at, and then now you understand how things connect. And the one word that I'd like you to take away when you hear schema is basically gives you structure for your data. Schema, structure. Okay? So database as well. I want to get you the simple keywords because I know you guys read the textbook. So basically, database is somewhere you store your data in, and you can do retrieve operations. You can create, read, update, delete, which we call CRUD operations. Why do we use database? Because one, they keep things organized, right? The second is we decouple them, because back in the days, we have file systems, and in those file systems, we have to have their own, kind of like their database. So every file system has their own way of putting data, putting the stuff in. But now if you have a separate database, you can have different systems interacting with that one database. Okay? So we were presented with 3-level schema. It's a very interesting graph in the textbook. I'm going to go over this, which is external schema, logical schema, internal schema. It looks complicated, but we'll break it down easily. So first, external, logical, and internal. So the 3 levels of abstraction, the first one is external schema. Think of it as the view. What is a view? So if you see something with your application you open, that's a view. Graphical user interface, that's a view. You open a website, you see something, that's called a view. Okay? For the second schema, the conceptual schema, that's basically your logic. Logic meaning what is being done, like being processed. What, like, is there data validation? Are we gonna extract something? Are we gonna do something? It's a process. Okay, so something logical. So if you're also doing development, that's what you should be focusing on, your business logic, your algorithm, whatever. So the last schema is internal schema, which is physical. It just means the physical stuff, where you store stuff, the physical hard drive. Okay, let's add more things. So because it's a 3-level of abstraction, whenever you have more abstraction, the user knows less of what's inside. So think of it like if you have a coffee machine, if something was broken, do you really break it apart and go inside? No, because that level of abstraction lets you just push the button on and off, and if it breaks, you ask someone to work with it. So as a user, you just need to learn how to turn on and off. So that's what we call abstraction. Go ahead.
Is the schema is different with the schema in the MySQL?
So there's different types of schema. I would say yes for now, it's a different thing. There's different types of schema. Again, schema gives structure, right? So we'll move on and definitely reach that schema that you're talking about. So again, 3 levels of abstraction. View hides the rest of the database. Let's say you're interacting with Amazon, the retail store, right? Now you put something there, and you don't really see the database, right? That's it. Logical, you give the structure and constraints. So meaning, you would give the user some structure and constraints. Like what? They can only enter strings or numbers, or maybe they can only filter this category. So giving those structure and constraints. Physical again, physical storage, access part. And I have more with that, I think. So again, 3 levels of abstraction. If you're the user, you see the English text. If the logical, what it does is the English text converts it to SQL query. Now, because machine can only understand ones and zeros, you now need the logical schema to be passed on to the physical, which is converts it to binary. So think of it like this. I search in Amazon, I say TV OLED. That goes to the logical, and that converts it to a SQL query. Let's say select TV, TV from electronics where type equals OLED. So that's a SQL query. And now it will convert to 1000100001 because that's the way we store data in the random access memory or the physical hard drives. Okay? So again, if you add yourself, you as a user, you're here. These are external logical internal schema. Another example would be if you're facing an ATM, and in the ATM you see English text, right? And you punch in numbers, you put enter, cancel, whatever. All of those becomes like a query to retrieve data. And that query data itself becomes machine language, 1 zeros, 1 zeros. So here, this is the ATM view. This is the conversion. This is the conversion again. So you see the word mapping, and mapping, that's, we can say another word, it's basically it translates, it converts. Okay? So, yeah, so this one, model of a database system, you see again the users, you see the applications that they interact with, and then database management system. So let's say, again, you're using Facebook, that's your application. You search for your friend, and then now that would go to the database and retrieve that information and show it to the user again. Okay? So when I type, let's say, Clark, it will go to the database, and it will grab other things such as profile image, first name, last name, and I guess that's it. And mutual friends. Okay? So ATM mappings translation. So now, how do we even build our database? First things first, we need to know what are the requirements are from the business side. Now that we know that, we'll get that information requirements and we analyze. And from that analysis, we would now develop the physical design and also the conceptual data model to create the database creation scripts that would then allow us to create a database as well or implement the database. So here's an example of a notation that helps for the database development. If you try first in the blank piece of paper, you write stuff. Let's say, okay, my company has like a person, and my company has awards our employees. And let's say I have a project. So try putting all those words first and try to make association between them. So like this one is player as person can be a role of employee, player role of a person, and then a person qualification is held by a person. And now you would see a lot of this crow feet. Basically, this is a many, this is a single. So if it comes from, let's say, this side, a person has, to the employee has a one-to-many relationships. It means you can have a lot of employees from the person object. We'll discuss the object as well. So this is called the Ellis-Barker notation that helps you model a database. Again, the more you have experience in running a business, doing operations, the more that this would really make sense. But as tech, we also need to learn this stuff. So how do we create a table then? Very simple. You do use the clause, which is a keyword, create table, and then give the table a name, say a person, and now you add your column names and the data type, and whether it's null or not null. So if it's not null, your user won't be able to plug in the data without anything. Let's say for the name, I enter blank. It won't let me because it's not null. Okay? So you have that, resident at property number, resident at property postcode, birthday, NI number, and now you would also create a primary key and use person identifier as a primary key, and foreign key as these two. So when we talk about primary keys basically makes the table unique. So if we quickly go back here, so in Excel, you can just say that plug in all the data, and these are unique. The numbers here are unique. So you can say that this is your primary key. You're never gonna have another one. Okay? You're never gonna have another 10. Okay? For foreign key, just to make it simple for now, when we say foreign key, it's basically a primary key from a different table. So it's saying here that these two comes from the table property, and there are a foreign key. It means they're a primary key from the other table called property. Go ahead.
I had a question on the not null. So like for example, if it's not null, you have to enter like the postal code, but if it's null, you can leave that blank. Is that what you're saying?
Yes.
Okay.
So it's one of what we call input data validation. And it's a good example when you're doing login and signups. You can't ever leave a blank password.
Because they're not null.
Yes.
Okay.
Yep. Data modeling concepts. So we'll dig deeper in what it is like this create table person. So person, you can say it's a thing, it's an object, and commonly called in the database world, it's entity. Okay? Entity. So object, person, thing. You have employee, person, teacher, whatever. That's an entity. Now, when we talk about the things that the person may or may not have, it's called attributes. So it's piece of data about the object or entity. If you have employees, you can have an employee number. They have the first name, last name. They have a health plan enrollment. They have work location. And here's another example. And this is Sakila database. It's one of the known sample databases that you can just download and play around with. Just type SAKILA, and you'll get this database as well. So, for example, your film is your object or entity, and the attributes for the film, you have the title, description, release year, language ID, original language ID, land, replacement cost. And if you go back, primary key is film ID. You can see it with the notation of PK, primary key. And now it uses foreign keys with the notation foreign keys, FK and FK as well. So like in this example, in the film, in one film, you can have many actors, but you cannot have many films with one actor. Did I say that correct? Okay. So let's move on. This is a good, it's from Mendix, but because they also talked about database concepts, and this is a very good visual representation. This product, the strawberry jam, is your object, and your attributes could be the name, which is a string, or a varchar database, expiration date, date time, price, decimal. Production number, it says auto number, but it's also an integer. Why do we use integer? Because we don't really need the decimal places. It's like, what's your age? Do we say, I'm 29.5? We don't even say that, right? So we don't need to do decimal. And the reason why is, why do we choose integer if we can use it? Because it uses smaller memory than using decimal places. Okay? And that's why also when we are using varchar for text or string, when we do first name, last name, and then compare it to the address attribute, we usually have, let's say, varchar 25, meaning 25 characters. And then for address, we can have varchar, let's say 150, or maybe just 50. So 50 characters. Wow, it's snowing. So we've been talking about attributes, entities, and we basically got a lot of data, and all of those are, you can say, unnormalized if we just obtain them. And unnormalized data is really painful for us because it's like going to Netflix and browse. It's like that. So we have to give them a structure. That's why we're doing databases, is to give them structure to easily use and manipulate them. So we'll now deal with the first normal form. So first normal form states that we have to eliminate repeating groups in individual tables. Also have to create a separate table, separate entity, for each set of related data. We also have to identify each set of related data with a primary key. So it says every table should have a primary key.
Oh, wait.
Go ahead.
How to determine a primary key if we have two or more column that has unique value?
If we have two or more column that has what?
Unique value.
Unique value?
Or unique something inside, because the primary key couldn't have the same value, right?
Yes, so they're unique itself.
Like I have a username and an email address that both are unique. How to determine which primary key?
That gets into
Second normal.
Set.
Yeah, that gets into candidate keys.
Yes. So we'll do this first and we'll get to that second normal form. So first normal form violation, an example would be, let's say you have a student's table and you have a column. Again, think of this as like an Excel as well. It looks the same. So you have column names, roll number, name, branch, HOD, office telephone number. This is your primary key, 1, 2, 3, 4. Okay, your names. And now this has been highlighted. Why? Because now you see that whenever we have the branch CSE, we basically have the same HOD. I guess that's a supervisor.
Head of department, maybe?
Yeah, head of department.
Good.
And telephone number. So whenever we put another CSE, we create the same thing. So why is this a problem? Because now, whenever we add a CSE, we have, let's say we need to change CSE, right? Now, we have to change this as well. That will cost you resources for doing that operations. Okay? So how do we fix that?
The branch as a front.
So
Frontier key.
again?
Set the branch as a frontier key.
So you would basically create, yes,
Two tables.
foreign key, yeah. So before that, this is an example. Let's say you change this. Now I have to change every row. Let's say, oh, the supervisor changed. Now I have to change every single entry, which is pretty bad in terms of like processing resources. So how do we fix that violation? Is basically create another table called branch, and next is create this CSE and use it as a foreign key. And now that key would now have the supervisor and office telephone. What's good with that is if I need to update something, I only need to update this table and only this entry. And I just need to pull this data and I get that data as well. So again, first normal form, you have duplicate data in one table, separated in another table, and just reference from that, meaning use a foreign key. Use that primary key to the other table, and that becomes the foreign key.
So the student table becomes a foreign key?
Or
the other one?
No, it means that student table now has primary key and now has a foreign key. Okay? And just to clear that out, branch table has also usually it should also have a 1, 2, 3 here. But in this case, looks like the primary key is the branch. I think here's another example of a violation is when you look at the telephone number, it includes a lot of numbers, right? That would be hard to use because let's say you retrieve a data and let's say your app has like call this number right away. What if those two numbers pop up in your message app and then you click call? Would you be able to call them? No, right? Because they're showing you as one string instead of like just one number. So to remove that duplicate as well is maybe you can create 1 and 2 and you can keep going with that if you want. But that doesn't really fix it right away. The next thing we do is basically create a customer name and customer telephone number. You see the creating a new table to fix the first normal form violation. Now your customer name has a primary key with this one, and your customer telephone number has this one, primary key, and with the foreign key with this one. So meaning customer telephone number table has foreign key customer ID, which is a primary key of the customer name table. Let that sink in, because it's gonna go deeper. See? So why do we do that? Less redundancy, less problems in insert update read. That's what I showed you earlier with this one. Okay? Second normal form. First, it has to be in the first normal form. Second, every non-prime attribute of the relation is dependent of the whole every candidate key and should not have partial dependency. Okay, example. So in this case, we have what we call score table, and it has attributes or column names. The score ID, student ID, subject ID, marks, teacher. So if we can look at this, we have the teacher having a partial dependency on the subject and not the student. Why? So every time I see subject ID 1, I see Mr. J. And every time I see subject ID 2, I see Mr. C++. But look at this. If I have the student 10 and 10, I have different teacher. So it's not dependent on student ID, but it's dependent on subject ID. Why is that bad? So now, when we remember in the first normal form, if you have something like this, let's say something like this, but it's dependent on this one, that's a violation for first normal form. But in this time around, because we have a candidate key or composite key, or meaning you have two foreign keys, okay? That now becomes a composite key. And now this column is now dependent on those. Okay? So, okay? Oh, composite keys are student and subject. Okay? Remember, when I say these are foreign key 1, foreign key 2, take them together, becomes composite key. And again, what is foreign key? It means that we have a student table that has these numbers as well, and we have as a primary key, and we also have a subject table that has this number as their primary key. And then we use this in the score table. That's why they become foreign key, and now we put them together, we have a composite key. So why are we doing that? Because these two can make the table more unique and more usable for us. So just to have an example, let's say I'm going to give you out your grades. I can't just say, I'll give you ID number 1. You don't know if it's yours either. But what if I give you your student ID number and the IS306? Now you would know right away that it's yours, the grade that I've given, right? Instead of saying, I'll give you 3. What's 3? Doesn't make sense. I'll give you student ID number plus your course number. Now that makes sense if I get the value from that. Hey, as always, we create another table. More tables, more fun. What we try to do now is basically remove this and put that in the subject table. And now we have the subject name. And actually, let's see if we have another one. Yeah. So we would have first a subject table that has those. And we create a teacher table to separate that. So now, why are we doing that again? I really want to clarify is because when we go back here, if we make changes for the professor for subject ID 1, we have to change every entry. You don't have to do that. That's why we create a table so that we only need to update this table and just only one entry. And now we can just do relational stuff and connect them together when we query or retrieve our data. So like, yeah, joining, like date of joining, salary, etc. going through. Another example would be something like this. You have the electric toothbrush models, and you have manufacturer, model full name, manufacturer, country. Can anyone spot where's the partial dependency?
Manufacturer real and the manufacturer country. No.
Manufacturer
Correct.
country. She's right.
You're right. Yeah. So again, the problem with this is if I'm going to update the country, I have to update every country for that specific manufacturer, which we don't want to do. So we have to separate them in a different table. Here you go. That's what happened. So far, so good. Okay, we're gonna go to third normal form. Okay, first it has to be the second normal form. No non-prime, non-key attribute is transitively dependent on any key. For example, no non-prime attribute depends on other non-prime attributes. All the non-prime attributes must depend only on the candidate keys. Wow, that's a lot of prime. So example, okay? So for example, we have the score table again. We already defined the student ID and subject ID as our candidate keys or composite keys. And now it's saying that the exam name is not a part of primary key, but the total marks depends on this one. This is called a transitive dependency. The difference between that, the second normal form is, this is better. The teacher is dependent on the candidate keys. That's partial dependency. And total marks does not depend on either the primary key or the candidate key. It's only dependent to a column name. Again, it's not a primary.
That looks like it is dependent on student ID and subject ID, but I think the three of them together could form a primary key to the table.
Yeah, you may be correct. Let's see. So exam table, we first try to create a different table from that. Oops, it's on the example. But let me try to get back to that third normal form to verify. It may be correct as well. Okay, but the takeaway for third normal form is if your total marks is dependent on a non-primary key, and I guess exam name is dependent on the candidate. Okay. So another example for this violation. The tournament, the winner's date of birth is dependent on the winner. Let's see. So they basically separated them. Because again, the winner is not a primary key in this table. I'm thinking it's gonna be the tournament and tournament year as the candidate keys. So that's all about third normal form, and I'll discuss the other normal form because of the muddiest point, but for later. Have a question? No?
No.
Okay. So for database, our standard is we always want it to be ACID compliant. We hear ACID compliant all the time. So it's basically atomicity, consistency, isolation, duration. And I know you guys read the textbook, so I'm giving you a more simple meaning to them. When we say atomicity, it's basically success or failure. There's nothing in between. If you make a transaction in the ATM, it's just success, get the money, or fail, enter the wrong pin. It's never in between. It's never, let me check, maybe it's a yes or no. No, it's yes or no, and it's never in between. Consistency prevents corruption from illegal transactions. When we say illegal transaction, an example would that be is, let's say someone wants to change your data, and then you're not authorized to do so. Or let's say this data is dependent on other data and now is gonna
Deadlock. Deadlock. Right?
Yeah, deadlock or basically affect that other data. So that also is isolation. It's an incomplete transaction, not visible. Okay, it's isolated, and that's why we have databases instead of them in the file systems. Duration, these are recorded in non-volatile memory. Non-volatile meaning the hard disk, right? And before we do activity time, I guess we can take a 10-minute break. Okay. I'll quickly move on with, we're done with activity. We'll do muddiest point. Why use computer language to write to the database? The answer to that is because computers only understand computer language, which is machine language, ones and zeros. So we'll go back to the three-tiered schema. We have the first one, which is the external, which is the view, and that's English text. Now it gets translated to a SQL query by the conceptual schema, or what we call logic as well. And then from that SQL query, we'll now convert that to ones and zero in the internal schema, which is the physical part. So that's the answer. Computers can only understand ones and zeros. Why is that? I think it's faster for them to understand ones and zero, the flipping of switches. How is it different from traditional numbers and text to write a database? They are stored in binary numbers, and when you access the data, they show a graphical representation. It means that, again, we only see external going to the conceptual, going to the internal. It also happens the other way around. When we retrieve data, it goes from the internal to the conceptual and to the external. So the ones and zeros gets converted back to text. So How is it different from design? Yeah, that's. I guess if I let me know if it did not answer that correctly. Another normal form. So Boyce code normal form should be in third normal form first, and A should be a super key basically.
What is super key?
Let's see if I can try to explain that. So given a college enrollment table, you have student ID, subject, and professor. So in this case, you would see that Java has Java. Oh, this is the problem. So you have subjects, you have different professors as well. Okay, move on to the next image. What happens with that because is you have the student ID and the subject as the candidate key, and now that defines the professor. Or you can go back here. So this one and this one, that one. Yes.
Oh, but you can't derive student ID from professor.
Yes. And then the next one would be the professor can find the subject. So meaning, if I always search for Professor Java, I'll always get Java subject. If I search for Professor Java 2, I'll always get Java as well. So that's what it's saying there. Okay? However, the professor is not a super key. I think I forgot what a super key is just because it's super. So, and now, basically what they did is we always separate the tables and make relationship. That's why it's always called a relational database management system or relational databases. So what happens here is student ID is now with a professor ID, and that professor ID now has the professor name and subject. So as we go on, it's kind of confusing. I don't know if I really answered it correctly, but it's more complex. But usually they only ask first, second, and third normal form, and you should be fine. But I guess if you want to be more of like a database administrator, maybe business analyst, maybe you need to know this stuff as well, because there's a lot of normal forms. So we'll move on that one. How to protect the company's privacy if they need to use other companies' tool to analyze their data. Well, a lot of people move their data to the cloud. So with that, we're thinking, oh, it's more secure, but not really. You're just giving the responsibility to the other party. So there's also dangers of the cloud. What if your cloud provider steals your data, right? You don't know. They're using your big data or whatever.
Promise you that doesn't happen.
Obviously, that
Facebook.
doesn't happen. Yeah.
Facebook.
So we may never know because you just click, trust everything. That's a problem. So another way to protect though is hopefully they uses the data encryption, meaning you send the data for them to analyze for the third-party vendor, and hopefully in transit they encrypt that to whatever SHA-256, AES, a lot of different encryption standard, and hopefully that protects the data and not be corrupted. So any manager can manage at most one department. Why you need to, I think this was a question for the knowledge check. And if you're kind of lost, ambiguous, you have to make assumptions right away. Because this is especially true if you're doing interviews as well. If you're given a very open-ended case, if you try to solve it right away, you'll end up saying a lot of different stuff. You're gonna go zigzag to your answer. So you have to make assumptions that, oh, I assume that only one manager can manage one department, which is most of the time.
I think the question is depend on the graphic in our textbook.
Yes, actually, now you know. Yeah.
It's not like a rule in the real world.
Correct.
Because in real world, the company have a different use case.
Correct. So here, that's another good keyword that she said, use case. A lot of us has normal forms to normalize data, remove duplicate, but if you have the use case of needing duplicate data for some reason, go for it.
Usually the reason why is you have to query that data a lot, and you'd have to do a lot of table joins, and table joins are expensive.
So the basic idea is if you need to modify the table frequently, you need a normalization. And if you only need to read those tables, it's denormalization is better.
Well,
It's based on the amount of accesses.
yeah.
So if you are running Twitter for Pets, startup, you have a couple hundred customers that pay you money. Your customers table, you're going to want to fully denormalize it to keep your data store robust. Whereas if you have Microsoft's Azure customers, they have tons and tons of them, and there are a lot of applications that need to know like certain types of data. So based on a customer ID, maybe there are a lot of Microsoft applications that need to convert customer IDs to email addresses. So even though email addresses might be part of a separate table, for example, you would consider moving those email addresses back into the central table just for the purpose of just because that means that instead of having to do like a bunch of complicated joins to get that data together, you just need to do one.
Yeah,
So
so
it's faster.
to add, again, to try to explain it again with her keyword and his example, again, let's say you always need to give to the user the first name and the favorite sport. And let's say that hobbies is in different tables. So if you have a lot of read, meaning a lot of people clicking to access that first name, sports name data, so why not just put them together, even though it does not fit the rules, right? But because you're now thinking about the resources spent for that processing, for that computation. And again, resources spent is money, okay? Money, money, money. Surrogate keys. I kind of got lost as well, so feel free to read the definition. A surrogate key in SQL Server is created by assigning an identity property to a column that has a number data type. A surrogate key is a value generated right before the record is inserted to the table. So
I have a thought from my SQL course that I took with. So a surrogate key, think of it as an artificial primary key. So you have like various data, like let's say I have a table of people and I'm only recording like on my intake form first name and last name. Well, that doesn't help me when I'm trying to query a database because there might be 5 people named Josh Smith. The surrogate key generates an arbitrary guaranteed unique value to use as a primary key. Like a lot of our student ID numbers, employee ID numbers, like all that stuff is actually a surrogate key because it forms the basis on which all of the other records are accessed. You don't really, before the logical schema is created, you don't have like a number to point to that says, oh, this thing, which is why people overuse social security numbers on everything and why it took a long time for us to migrate off of that.
Good example. Thank you for sharing that. So before I make you guys go for a break and then do hands-on session, I'd like to give some feedback because usually we just check hands-on practice with, pass, good job. But I kind of want to look into what you guys are saying. So here's some of my comments in general. Typos, please avoid typos because once you're working now and you're contributing to the documentation, that's kind of like a small thing that you can easily fix right away and should not be even going through the master documentation, whatever. So for me, even though I can speak English very clear, I still use Grammarly just because it's more intelligent than me to spot my typos and error. It's better than Microsoft Word. It's free. Syntax highlighting. Why? Because if you say, in this exercise, I used the show database, and then you didn't put any syntax highlighting, new users or beginners would confuse, is that a syntax error? He said he was showing the database, but you're implying what you want for them to understand that it's a command. So for now, I just want you to find your own standard for now. Let's say, okay, I'll make it bold. So all of my commands, when a user see, if it's in bold, it means it's a command, right? If it's italicized, maybe it's a command. For example, hyperlinks is always in blue and underlined. So definitely your commands should also have a certain standard as well. Okay, you would learn that more often than not, when you go search internet search as well. Git is not, I forgot what was it, but just to clear up, Git is a version control system. It lives in your Windows, Mac OS, Linux. Most of the time you install it, but I think right now it comes pre-installed. So basically Git is your version control. If you do Git init, it can track your version. Let's say you create lecture 1 slide, right? And then I do git add commit. It saves that version. And let's say I edited my lecture slide, and then I do git add commit. What happens there is I now have 2 versions, but when I open my graphical user interface, meaning the file explorer or the finder, I would just see 1 file. But when I hit another command to switch between versions, I would just see 1 file, but different versions as well. It's the same thing as when you go to your Microsoft Word and click, oh, give me this version yesterday. So Git is a version control system. And if you encountered GitHub or the Docker Hub as well, those are repositories that you can get data from, use. You can clone, or an easier word is you copy. You kind of copy. You clone stuff, okay? Spaces in command. What was I saying? Spaces in command. I forgot.
Blank. Blank space.
So don't forget either to, so when I was starting as well, a lot of my commands goes into error just because I forgot a space, I did not put a space, there's a semicolon, and most of the time as well, if I copy paste from the document, let's say your double quotes becomes a weird double quotes, because that's the way it translates when you copy paste. So be careful of that, with the exception of when you right click copy address, totally fine, paste it there, it should be fine. But other than that, if you're following a Word doc, copy paste, you might have an error. And another thing to note with that is, I'd like you guys, when you see the Word document, is you type it by hand. Because you learn more when you type it instead of copy pasting it. And you get that muscle memory, you get to have errors, which would make you learn more. Okay, so try to keep typing, and it increases your typing speed as well. And then next, you will learn to understand documentation in time. So it's fine, keep making mistakes, but please, please, please don't write that, oh, it was hard. It's fine, you say it was hard. But if you have the whole paragraph just saying it was hard, it doesn't make sense to me, it doesn't make sense to you. It's like you're just writing your feelings, right? I want you to write somehow technical in the sense that it would be useful to you. You know why? Because a lot of my peers, when I try to mock interview them, I would tell, do you have any experience with SQL, no SQL? They would say, no. I was like, what? We did learn it in class. Because they don't know they have learned it or they forgot about it. So one of the ways is this hands-on practice. So when you open up IS306 in my folder, oh, now I remember what I've done. And now at least I know how to talk about Docker. Again, it might not be relevant to your interviews. Let's say you're not gonna do infrastructure, but still, what if I meet this guy? He talked about Docker, and I can just say, oh yeah, I know that. Basically, you can put your apps and run a script, and now I can talk to him. And you may never know that person knows someone that, let's say, you want the job as a business analyst. So it's a conversation starter. So that's why another advantage for like me, I try to learn a lot of stuff. I can easily talk to a lot of people, even though it's way beyond my knowledge. like let's say complex algorithms, whatever, I can still talk to you and know about the simple stuff and keep the conversation going. So, and I really like you guys to, I can't emphasize more, keep talking, communicate, activities like this, and I hope you impart the knowledge good, whether it's wrong or bad. That's why, like, in your case, you like struggle, stuff like that, it's fine. As long as you can communicate properly, the other person knows your problem, he knows how to help. Instead of, I don't know how to even say, I have error.
There's a special rule about that on Stack Overflow too.
Mm.
If you just come out with, oh, I'm an error, or I got an error, they'll be like, okay, we're deleting your question.
Yes.
Okay.
So another reminder, if you ask for help in general, first Google, first ask your friend, and then before you even post the question, title, screenshot, all the what you call this, specifications of, okay, I'm using Windows 7, I'm using Mac OS, and then what version are you using with MySQL? So in that case, they would know right away what version number, and then try to replicate the problem and show it to them, or else they would be like wasting time just deleting it or just saying, so what is your error? I don't know. Okay, I guess we can take 10 minutes break and again, and do hands-on. Oh,
If I finish the
before that, let me just finish that one. If you finish the hands-on, I think you can really help Eugenio, is because he needs to be up to speed, and that would be really appreciated. So for hands-on practice, we would learn show databases. And as you can see, these are keywords. We can call them as clause as well. A clause can include the keyword and your parameter, which is any name you want. So use database name. This is a clause. And take it, everything, that's a SQL statement. So show tables, keyword, describe table name. So with this one, if you want to dissect it, you have the keyword select from. But if you say clause, you have select star, that's a clause. From table name, that's a clause. Take them together, that's a SQL statement. And let's see. Oh, so before hands-on as well, I have two. I guess we can quickly do this as, look at the table. I'll give 5 minutes on each. Pair up, a different pair this time. Write the answers in the whiteboard. I'll give you 5 to 10 minutes for this one. Come on, stand up, pair up, write your answers. This should be very easy. It's not out of the scope for this. The answer here is basically a select keyword, and your clause could either be select star, star meaning all the column names, or you can do something like this, with select column name, comma, column name, comma, column name.
That's technically better SQL.
And then from the clause is from is CD facilities.
Okay.
That's it.
That's it.
Yeah. So star is just a keyword for all the columns.
So select is expecting a number of column names from, so it's saying which portions of this table do you want. So when you say star, it's everything.
Yes.
Give me everything.
Just the same thing.
Yep. Now, typically the reason why it's considered
no,
better
you missed this
form to name your column is that if you don't want
You missed
data,
that.
it takes extra processing power to bring that data to you. So it has to consider more things. So if you know that you don't need everything, say like I want this and this.
So if I only want name and gas cost, I can just put
Select name, comma, gas cost from. Yeah.
Okay, next question. You want to print out a list of all the facilities and their costs
Does not
to
have
members.
to be end of line.
How would you retrieve a list of
SQL
only facility
does
names
not
and costs?
care
Question
about
Member cost or gas cost?
Expected response?
Okay.
right.
Next question, try to answer it in the whiteboard.
And then put
A list of all of the facilities.
Got the correct answer with the only difference is that your group, you did member cost, comma, name, which is fine, but because you're already given this expected result, you should do name and member cost first. But that should be fine as well. Okay, take a quick 5 minutes so we have more time to do hands-on. And for those who are done, please help one another.